Loading our new OneNote notebook. Once you have your tablet out and turned on, please open up Microsoft Teams. So again, to get to that, just start typing Teams into your navigation bar. Make sure you pick the option that says work or school. Doesn't matter if you pick classic or the new version. So again, you're opening up Microsoft Teams. In Microsoft Teams, you should see an 8th hour pre-calculus tab. I preloaded all of you guys into the class yesterday, so I think everybody should be there. Holler at me if you don't see it. Go ahead and click that 8th hour tile. And then from the navigation pane here on the left, you're going to pick Class Notebook. Take a moment for the OneNote to kind of load in there. Once it does, up in the upper right-hand corner where it says Editing, click on the drop-down arrow and pick Open in Desktop App. And that'll automatically open up OneNote and load in your new notebook for the semester. Once you've done that, my recommendation to you is to close your first semester notebook to avoid any kind of syncing issues. I've already closed it, so that notebook is won't be any changes happening. But I saw first semester people having issues with stuff syncing because they had old notebooks open still. So probably close that first semester notebook to avoid that happening here. Is anybody having an issue? We're all good? Okay. Why is there more? That's all right. You gotta take your carriers. That's okay. I'm just adding one more to your plate, babe. We're just sending them out. Package? Yeah. What? I think that is, dude. What is that? What's it for? I don't know. And it's right. Like last semester the tests were always like
I think what we're saying is yeah, all we do is like, I don't know if it's like black.
All right. So today we are going to be starting chapter 6. This will be quick because I'm not going to ask you to do too much here from chapter 6. So in chapter 6, what we're going to find is just we're going to look at some new identities, right? So if you look at the identity sheet I just handed out to you, it has the 4 groups of identities from first semester, the basic, Pythagorean, cofunction, odd, even. And then we have some indifference, double angle, power reducing, half angle identities that'll be new that we'll be using in this semester. Now remember last semester when we gave you these identities, we used them to simplify expressions, verify expressions, to do solving. We're doing none of those skills here with these new sets of identities. I'm not asking you to do that. You can, but we're not going to be using them to do that. Instead, the primary skill that I'm going to be interested in you being able to do sounds as follows. So I would ask you to do something like use the sum or difference identities to find the exact value of something like cosine 75. Now, when I ask you to find the exact value of a trig function, what tool does that mean that we're going to have to be using if we're asking for an exact value? The unit circle. The calculator will not help you because it will be giving you a decimal, which is rounded, which is not what we're going to be looking for. The problem is 75 degrees. Is that a unit circle angle? If you're not sure, go and flip your identity sheet over. There's a unit circle on the back. See if there's a 75 degrees on that unit circle. There's not. So, what are we going to be doing? Well, the directions say to use the sum and difference identities. So what I want to do to start is I want to find a way to rewrite 75 as either the sum of 2 unit circle angles or the difference of 2 unit circle angles. Does it matter which problem I try to do? No, it'll give you the same answer either way. So let's do the sum first. Look at your unit circle. There's one on the back page of your identity sheet. And see if you can find 2 angles that would add together to give you 75. Who sees it? Nick. 30 and 45. Very good. So we could write this problem as cosine 30 plus 45 Is everybody okay with that? It's now written as the sum of two unit circle angles. If I look at my sum and difference identities, this would be identity 3, SD3, right? Where I have cosine of x plus y. You guys see that on your identity sheet? So in our case, the x is the 30 and the y is the 45. So SD3 allows me to write this as cosine of 30 degrees times cosine of 45 degrees minus sine 30 degrees times sine 45 degrees. Everybody feel good on what I've done? So I've just used the identity like a formula, right? And plugged my numbers into the formula. Now, how do I do cosine 30 degrees, cosine 45 degrees, sine 30 degrees, sine 45 degrees? How do I do those? I look them up off of my unit circle, right? So look at your unit circle. What is cosine of 30 degrees? Square root 3 over 2. Blaine did that by reading the x-coordinate at 30 degrees. What is cosine of 45 degrees? Square root 2 over 2. And sine of 30 degrees? 1/2. Again, we did that by finding 30 degrees and reading the y-coordinate there. Remember, cosine is x and sine is y. And then sine of 45? Root 2 over 2. Everybody feel good so far? Okay. Now all we have to do is simplify this. So I see two things happening. I see multiplication and subtraction. Which one needs to be done first? Multiplication, because of order of operations. So how I see the multiplication is between fractions. How do I multiply two fractions together? Straight across. So I'd have like root 3 times root 2, and then over 2 times 2. Well, the 2 times 2 part is easy, right? Everybody should be comfortable there. How do I multiply root 3 times root 2? Anybody remember that from last year in your Algebra 2 class? So the rule is, if I have root A times root B, that's just the root of A times B. So what's root 2 times root 3? Root 6. Everybody's cool? Okay. What if I do 1/2 times root 2 over 2? What do I get there? Root 2 over 4. Everybody's good with how we got to there? Now we have two fractions that are being subtracted. To subtract two fractions, what do we need to have? Common denominator. Do I have that? Great. So now all I have to do is subtract the fractions with a common denominator. When I subtract fractions, the common denominator stays the same. And then how do I do root 6 minus root 2? It's not root 4. So this is not true. Nope. You can't. You can't subtract them. You just do that. Just write them next to each other. And we're done. Look at that. Was that too bad? We can do this, right? Let's do another example. Make sure we got the hang of it. What do you say? It's pretty good so far. Say we want to find the exact value of sine of 5 pi over 12. Ugh. What makes this a little bit harder? The fraction, right? Yeah, because like, how am I going to find two fractions that add to give me 5 pi over 12? That seems like a pretty big hassle, Mr. Kulik. What I recommend doing instead? Yeah, let's just convert 5 pi over 12 to degrees, right? We'll just make it a degree problem. What do I need to do to convert that to degrees? Times 180 over pi is correct. So the pi's cancel. 12 goes into 180 15 times. So 5 times 15 is 75. So sine of 5 pi over 12 is really just sine of 75. Let's try doing this as a subtraction problem this time instead of an addition, since we just did 30 plus 45 for the previous one. What two unit circle angles can I subtract to get 75? There's more than one correct answer. Look at your unit circle. Look at the angles that are available to you. Find two angles that when we subtract them give you 75 degrees. Blade.
So is the 5 pi over 12 radical?
That's not a radical. It's an irrational number, but it's not a radical because it doesn't have a square root in it. Miriam, do you see them? 300 and 225, sure. That works.
Oh, is it the smaller one?
Well, the smallest one would be 120 and 45. But this works, that's fine. There's lots of answers. Are they ever going to be unique, these addition subtraction problems? Yeah. Even 75, you could have done like 120 plus negative 45 degrees. But whatever, this is fine. So now we go to our identities. We look at the sum difference identity. Which sum difference identity is the one that we need for this sine 300 minus 225? SD2. Great. So 300 is like our x and 225 is like our y. So we're going to have sine 300 times cosine of 225 minus cosine 300 times sine 225. Everybody feel pretty good so far? What do we do next? We go to the unit circle, right, to find the values. So what's sine of 300 going to be? Negative root 3 over 2. Cosine of 225? Great. Cosine of 300? You're reading the y coordinate when you should be reading the x. 1/2, yep. Cosine is x. Sine of 225? Negative square root 2 over 2. Everybody good with how we did that? Again, this should be a skill we're pretty comfortable with. We've been doing it since like chapter 2. I think we've done it every chapter. Should be able to use that unit circle. Okay. Let's multiply these fractions. What do I get when I multiply the first pair of fractions together? Negative root 3 over 2 times negative root 2 over 2. Positive root 6 over 4. Very good. And then I notice here that Negative times negative, right? Or subtracting a negative means I should be adding. Square root 2 over 4. Very good. And when I add those together, nothing I can do with the numerator, so I just write it as a single fraction and I'm done. What do you guys think? This is pretty doable, right? Much easier than doing simplifying and verifying. Way less creativity involved. What if we ask you to kind of go the reverse direction? So we have sine 47 times cosine 23 minus sine 47, or sorry, cosine 47 times sine 23. When I look at this, I notice that the 47 repeats, the 23 repeats. So like the 47 is kind of like an x and the 23 is kind of like a y. So when I look at this, what I see is sine x times cosine y times cosine x times sine y. So now I'm going to go to my identity sheet and see if I can find that part of an identity. Sine x times cosine y minus cosine x times sine y. Does anybody see that? That's SD2. Allows me to write that as sine x minus y. And what is x again? 47. And what is y? And 47 minus 23 is 24. Single trig expression. What do you guys think there? No big deal, right? Was it even really necessary for me to write this down? Not really. I just did it so it would be really easy for you guys to see what it was I was doing in my head. What do you guys think? So far, so good? It's all right? Let's see. Let's do another. God bless you. God bless you again. Is there another one coming?
No, I held it. Just let out, bro.
You're usually good for at least 3 in a row.
I know. I've got my numbers down.
Okay.
I'm working on it.
Right, that doesn't matter. All right. So here it says we're going to be using the power reducing identities. So I'm going to flip my page over to the back and look at the power reducing identities. Which one of them is the one that I would need for this problem? The first one, PR1. So I can write that as 1 minus cosine. And now all that stuff is like my x, right? So when I have 1 minus cosine of 2x, I have 2 times and then 3 pi over 8. So first thing I want to do is do that 2 times 3 pi over 8. What do I get when I multiply 2 times 3 pi over 8? 2 times 3 pi over 8. What is that? Six pi over 8, which you could reduce to 3 pi over 4. Everybody happy there? Okay. How do I do cosine 3 pi over 4? Go to my unit circle. What is cosine of 3 pi over 4? Negative root 2 over 2. Notice that I have a negative or minus a negative again, so that's going to turn into addition. What do you think Mr. Kulik hates about this particular answer? A fraction inside of a fraction, right? Here's how we're going to take care of that. I'm just going to multiply the top and bottom by the denominator of the little fraction. Everybody's cool with that? So that's kind of what happens. Oops. Not 1 there, dum-dums. 1 times 2 is 2. What do you guys think? Is that all right? Final answer. Still feeling good? It's all right? Last one. We're going to find the exact value of cotangent squared negative 165. Again, we're using the power reducing identities was the direction. Go look at the power reducing identities. Which one of those would I need to use? Do you see a problem? Where's the cotangent squared? Bless you. It's not P2 because we have cotangent squared, not cosine squared. We're not going to use the h's. Here's what we're going to do. I know that cotangent squared is the reciprocal of tan squared, right? So that's just got to be that, right? Just the reciprocal of this thing. Does everybody feel cool? How would I do like secant squared? Reciprocal of cosine squared, etc., etc. Again, the first thing I'm going to do is multiply the 2. Now I just need to do cosine of negative 330. Oh no! Negative 330 is not on the unit circle. Whatever should I do? Excellent. Find something coterminal to negative 330. How do I do that? Just add 360 to those. Or you could just go around the unit circle in the opposite direction. You'll land at 30 degrees. So now we go to our unit circle and look up cosine of 30 degrees, which is? Excellent. Feel good? How do we get rid of the fraction inside of the fraction? Multiply by 2 over 2. Yep. Again, that 2 is going to multiply everywhere. Now, what's wrong? What's Mr. Kulik going to have an issue with this one? Still don't love this answer. Why not? What? Nope. Ah, square root in the denominator. Yes. How do I take care of that? Multiply by what? Okay, if I do negative root 3, the problem is that has to distribute. So when I distribute to the 2, I still have a root 3 attached to it. So that's not quite right, but you have the right idea. 2 plus root 3. Yes. So you're always going to use the conjugate. Now, when we do this, we have to make sure we're foiling, which stinks, but the denominator, if I look at this, that looks like a difference of 2 squares to me, right? A minus b times a plus b. So I know when I FOIL that out, I'm just going to get a squared minus b squared. And when I FOIL out the numerator, I get that. And now the squares cancel with the square roots. So I have 4 plus, well, let's do some more before I do that. And then those guys are like terms, right? So I have 2 root 3 plus another 2 root 3. How many root 3s do I have altogether? 2 root 3 plus 2 root 3. I have how many root 3s altogether? I have 2 oranges and then another 2 oranges. How many oranges do I have altogether? 4. So I have 2 root 3s and another 2 root 3s. How many root 3s do I have altogether? 4 root 3s. Everybody's okay there? So that becomes 7 plus 4 root 3 over 1. But the over 1 we don't even need. That can just become our final answer. That's like as bad as it'll get. Well, chapter 6. Again, depending on how much you remember from Algebra 2, this could be a very easy year because most, after we do these last 2 little trigonometry ideas, it's basically Algebra 2 stuff. So this is our stopping point. At this point, you should be able to do 1 through 10 in the homework.
Do this on that?
No. Yeah. So again, you're just doing what we've done in the homework or in the examples here. Everybody's cool? Okay. This feels like a good place to stop. I'm stopping here.